Hello and welcome back to the Maths Behind the Economics YouTube channel and to the Logarithms for Economics series. This is video 5 and this is the first video when we talk about some special logarithms. In this episode, we're specifically going to talk about when logarithms are equal to 1 and y and when logarithms are equal to 0 and y. And I'm going to show you plenty of examples as always. Let us get started. First, I would like us to have a little think about when logs are equal to 1. So, for example, if I wanted to find out log 3, what would that be equal to? Well, remember, what power do I need to raise base 3 so that is equal to 3? Well, 3 to the first is equal to 3, so log base 3 has to be equal to 1. What happens if I have log base 10? Well, again, what power do I need to raise 10? So the answer is 10. Well, every number to the first power is equal to itself, so 10 has to be raised to the first power so that it will be equal to itself. So log base 10 is also 1. How about log base 5? Same logic. What power do I need to raise 5 to get 5? Well, 5 to the first is equal to 5, so log base 5 is going to be equal to 1. I want to show you one last example before we move on to the generic discussion of why this is true for any base, and that's going to be ln of e. What is that equal to? Well, what power do I need to raise e so that is equal to e itself? Remember, ln is a specific base, so ln of any number a is the same as log e base a. So the ln starts for logarithm natural and that's the e base logarithm. Remember, e is a number that is roughly equal to 2.71 and some other digits. And this is just like pi, one of those irrational, never-ending, never-repeating numbers. But back to the question at hand. What power do I need to raise e so the answer will be e itself? Well, any number including e raised to the first power will give me itself back. So ln of e is always going to be equal to 1. The next question, is it true for every single base? And if it is, then why? Let us make some more space and start to think about the general case. So if we take any base logarithm, b is going to be the base, with some argument, we know that the answer is going to be equal to some power. Why is this true? Because we remember that b raised to p is equal to a. Remember that in the first video we discussed in detail this intimate relationship between logs and exponents. Now, what's special about our case? Well, in our case, the argument is equal to the base itself. The question is now slightly modified and I'm basically asking, what is log base b equal to? I have to raise b to some power, so that is going to be equal to b itself. Now, any number to the first power always going to give me back itself. So, when we change the argument to b, we got b to the p equal to b itself, which means that p has to be equal to 1. So that's why log base b equal to 1. So let's change the question mark to 1. And again, there's a special case in here. Remember that ln of e is basically the log e base of e. So here the base of the log and the argument are the same. So again, it's going to have to be equal to 1. So that's why whenever you see ln of e, you can just replace that by 1. Let us make a little bit more space again. And now let's try to answer the question, when are logs equal to 0? Again, let's start with some examples. So I've got log base 3 and the argument is now 1. What is this equal to? Well, remember, what power do I need to raise 3 so that the answer will be 1? Again, to be able to answer these questions, it is very important that we fully understand and remember well the exponents. So, we remember that any base whatsoever, including 3, raised to the 0 power is always equal to 1. So this log base 3, 1 is going to be equal to 0. Next example, log base 10, 1. Same logic. 10 raised to some power have to be equal to 1. Well, any base including 10 to the 0 power is always equal to 1. So log base 10, 1 is also equal to 0. What happens to log base 5, 1? Well, now you probably get the drill. 5 to some power have to be equal to 1. Any number to the 0 power including 5 is equal to 1. So log base 5, 1 has to be equal to 0. Last example, because in economics you're going to have to work with the natural logarithm. That's why I like to show the ln examples specifically. So ln of 1, what is that equal to? Well, with ln, we have to remember that the base is e, so I have to raise e to some power, so that would give me back 1. But again, because of the definition says any base including e to the 0 power is always equal to 1, so ln of 1 will still be equal to 0. Next question, why this is true? So let's look at and discuss the underlying theory. So again, let us make some more space and go back to the generic definition of the logarithm. So log base b a argument is equal to some power. If and only if the same base to that same power is equal to the argument or the answer itself. So let's discuss what difference does make if I change the argument to number 1. So what happens if the argument is equal to 1? So log base whatever 1, what power is that equal to? Well, b raised to the power have to be now equal not to just the argument but the specific argument of 1. Again, because we remember that any number, any base to the 0 power is always equal to 1. So if the argument is 1, then that tells us that the power has to be equal to 0. There is no other case. So that's why it doesn't matter what base we have. If the argument is 1, the log always gonna cancel down to 0. And again, in a special case of ln, ln of 1 is going to be equal to 0. So let us quickly summarize the gist of this video. What is the important takeaway? So the most important takeaway here is that if you have got a log with some base and the argument itself is the same base, then that log always cancels down to 1, including ln of e is always going to be equal to 1. But if I have got some log base 1, that's always going to be equal to 0, including ln of 1 can be replaced by 0. I hope you learned something new in this video. In the next video, we're gonna do another episode on special logs, but in that case, we're going to look at when logs and exponents cancel each other out. I hope to see you there. Thank you for watching. Bye.